Numbers 14 and 15 are next on the review. Number 14, I want you to notice the difference between 14 versus 15. Notice that 15 has 3 pieces here. It has 2 pieces on the left side of the equal sign. It's going to be worked differently than number 14 is. If you look at number 14, you should recognize this type of problem from seeing it before in Algebra 1. It's just a proportion where you have one fraction equal to another fraction. And to solve that one, all you really have to do is cross multiply and then solve. So on the left side, I'm going to have x minus 2 times x minus 4 equal to, on the right side, I'm going to have x plus 5 times x minus 6. Now you can either use the FOIL method, you can use the box method to multiply these, however, whichever method suits you best. I'm going to use the box method. I'm going to put x minus 2, this is for the left side, and then x minus 4. And here we'll have x squared minus 2x minus 4x plus 8. And remember that this diagonal here will always combine, so the left side is going to be x squared minus 6x plus 8. The right side will work the same way. I'm going to draw a box here for that one. I've got x plus 5 and x minus 6. This will be x squared, 5x, minus 6x, and then minus 30 there. So it'll be x squared minus x minus 30 when you combine this diagonal here. And now what you might notice is that both sides have an x squared. So if you were to subtract x squared, potentially to, move it over or combine your like terms, those cancel out. And you're left with negative 6x plus 8 equals negative x minus 30. So I'm going to add 6 x's so that I will end up with having a positive x value. 8 equals negative x plus 6, 5x minus 30. I'm going to add 30. So 38 equals 5x. And now we need to divide by 5. Divide by 5. And you can either leave it as 38 over 5, or you could get a decimal. That would be 7.6. Honestly, either way is fine. Most of us will just put 38 over 5 for the answer for that one. So that's number 14. Now we're going to look at number 15. Number 15 is worked differently. Just like the previous problems, what we need to do in order to get rid of the denominators here is we need to figure out a common denominator and then multiply each piece by that common denominator in order to eliminate our fractions in this problem. So I need to first decide what the common denominator is going to be. If you ever have a whole number, you can write it over 1 so that you can visualize the denominators for each of them. Remember that c minus 12 is totally different than c by itself. So you have to treat these as different items. And remember that with the common denominators, like on the previous problems, we need to have one of each different kind of denominator. So if there's any different pieces, we need all of them. So we don't need to write 1. We're going to need c in our denominator for sure, and we're going to need c minus 12, which is very much different than c. So we need to have c times c minus 12 for the denominator that I'm going to be multiplying each piece by in order to eliminate my fractions. So I'm not going to draw a fraction like I was on the previous one. I am going to be looking at each piece and multiplying it by c times c minus 12. So I'm going to write that over each piece so you can visualize your multiplying by that. And this way you can see what will cancel. So on this first one, what is going to cancel is the c minus 12 that was on the bottom cancels with c minus 12. And you have c times c, so that one ends up being c squared. On the second one, the c on the bottom cancels with the c up here. And you end up having, and it was a plus, so we're going to have plus 6 times c plus, or minus 12. Sorry, that was the 12 there. Hard to read. On the right side, there was nothing on the bottom, so nothing cancels out. So you have c times c minus 12 on the right side. So I need to distribute here to simplify, and then I can also distribute here and then solve. So I have c squared plus 6c minus 6 times 12 is 72. And then on this side, c times c squared minus 12c. And again, really excited about the fact that both sides have a c squared, so that when I subtract, they cancel, and I'm not going to end up factoring. I now on the right side, and I'll copy this so it's easier to see, minus, 6c minus 72 equals negative 12c on the right. I'm going to have to move my 6c over there because there was only c's on the right side, so that's really the easiest way, even though I will have negatives. Negative 72, negative 18c, and then divide by negative 18 on both sides. Negative divided by a negative is positive, and 72 divided by 18 is 4. So the answer for this one is that c equals 4.